Dumelang bafethu and welcome to another practice question. Question number 7, electric circuits. So, the statement goes as follows. The circuit diagram below consists of 4 cells, each with a voltage of 1.5 volts. That should be the first thing you underline in your question. They say the resistance of bulbs A, B, and C are 3 ohms, 6 ohms, and 8 ohms respectively. Use the circuit diagram to answer questions that follow. So you're given this illustration and you can see there's a battery that has 4 cells in it. And as it has 4 cells in it, they said each cell in that specific battery has a voltage of 1.5 volt each. That should give you a hint of what you're expected to do. Okay. And then you have 2 resistors that are in parallel. So you should remember, resistors that are in parallel, what will happen? Current splits, the total current in that specific circuit will split, but the voltage will remain the same. Number 1, for both A and B. Number 1. Okay. And then you have resistor number C. And as resistor number C, you can see it is not in a parallel format with any other resistor. It's just a standalone resistor. That means what? That means it is a resistor that is in series. Gives you a hint, resistors that are in series, current does not split. Remains the same. Therefore, that means what? The total current of the circuit is the same as the current that the resistor C would have. Finish. But what will happen to the voltage? The voltage will split in resistors that are in series. Number 1. Okay. And then you have an open switch and you have an ammeter. Ammeter will do it. As you can see, the ammeter is not in any parallel format with any other resistor. The ammeter is just a standalone ammeter there. Therefore, it means what? The current that will be read by the ammeter is the total current. It would have been a different nature if the ammeter was standing next to next to resistor number B. It would have been a different nature. But since the current is a standalone ammeter, since the ammeter is a standalone ammeter, is just standing over there with no resistor, it will read the total current. Simple. I hope you understand. Okay. Then the statement goes as follows. When switch S is closed, what will happen? Charges will flow. Number 1. The reading on the ammeter, which is A, is 0.6 amperes. Therefore, what does that mean? In your answer, you should know, in your question paper, you should indicate already. Therefore, 0.6 amperes refers to what? Refers to the total current. Because why? The ammeter, as it is not in a parallel format with any other resistor, it will read only the total current. Therefore, the total current in this regard will be 0.6 amperes. That should be the first thing you focus on. Okay. 7.1. Define the term EMF. What is meant by EMF? I said you can either choose to say the work done per unit charge by a battery or a source, or you can choose to say the maximum amount of energy transferred per unit charge. Those are the definitions that I know of and that I think you should also know, or maybe your teachers will give you another different definition. I don't know. But yeah, EMF is the maximum amount of energy a battery can supply. Simple. You get your 2 marks, you're done with it. And then question 7.2, they say that write the EMF of the battery. What did I say about focusing on EMF? I said if they look for the EMF, you look for what? You only focus on the battery or the source. How much energy will that specific battery supply? Okay, as it is said in your illustration, they said the battery has 4 cells and each cell has how many volts? 1.5 volts each. Therefore, how are you going to go about calculating the EMF? EMF is equal to, you say, the number of cells that you have in that specific battery. How many cells do you have? You have 4 cells in it. So you're going to have 4 multiply by the number of volts each cell has, which is 1,5 volt. And therefore your answer would be what? Would be 6 volts. That means what? That means your EMF is what? Is 6 volts. You get your 2 marks, you're done with it. Simple. Okay. Question 7.3, they say, if the reading in V3 is 4,8 volt, V3 is a voltmeter and it reads what? It will read the voltage. V3 reads or the voltage used by the resistor C is what? Is 4,8 volts. Therefore, that means what? That means resistor C, when you're calculating, you're going to know resistor C has a voltage of what? Of 4,8 volt. Number 1. Keep that in mind. So, question 7.3.1, they ask you, calculate the effective resistance of the circuit. So if they say effective resistance, they're speaking about what? They're speaking about the total resistance of that specific electric circuit. How do you go about calculating total resistance? The formula to calculate total resistance is RT is equal to R parallel if you have resistors that are in parallel plus R series if you have resistors that are in series. So you go to illustration, you look, okay, do I have resistors that are in series? Yes, I do have resistors that are in series that are not in a parallel format with any other resistor. That is just a standalone resistor. As you can see, resistor C is the only resistor that does not have any resistor in parallel format with it. Therefore, RS will calculate the resistance of C. Do you have resistors that are in parallel? Yes, you do have resistors that are in parallel. Which one? A and B. V2 is not regarded as a resistor, it's a voltmeter, guys. A and B are the only two resistors that are in parallel format with one another. So, that means the formula you can use it most. So, the first step, what you're going to do, calculate resistor parallel, calculate resistor series. R parallel. What is the formula to calculate resistors that are in parallel? 1 over R parallel is equal to 1 divided by resistance of A plus 1 divided by resistance of B to indicate where you are dealing with A and B. The formula will end in 1 over RB because there are only 2 resistors that are in parallel. If you had 3, it would have continued. Okay, simple. And therefore, 1 over RP is equal to, what is the resistance of RA or resistor A? It is what? 3 ohms. So you can have 1 divided by 3 plus 1 divided by RE. What is the resistance of RP? 6 ohms. Therefore, you're going to have 1 divided by 6. 1 over RP is equal to 2. Take the 1 over 3 and the 1 over 6. You insert it as it is in your calculator. So you can have 1 over 3 plus 1 over 6. And then your answer would be 1 over 2. But you're not looking for 1 over RP. What you're looking for is RP alone. How are you going to go about calculating RP? Take at the bottom, put it at the top. Take what's at the top, you put it in the bottom. So you're going to have RP divided by 1 is equal to, what you do on your left hand side, you do it on the right. Take the 2, put it at the top, and take the 1, put it at the bottom. Therefore, your resistor parallel will be 2 ohms. That's the final answer. So you now have the resistance of the resistors in parallel. You move. Resistors that are in series, RS. The formula to calculate resistors that are in series, which one? RS is equal to, depending on the number of resistors you have in series. In this instance, you have only C as a resistor that is in series. So you're going to have the resistance of C. And then you're not going to have plus something something because it only ends at C. If okay. RS is equal to, what is the resistance of resistor number C? 8 ohms. Therefore, that means what? That means our resistors that are in series has a resistance of 8 ohms. Finish. But that is not what you're concerned about. You're not concerned about resistance of resistors in parallel or resistors of resistance in series. What you're concerned about is the total resistance of the circuit. You go back to the formula. RT is equals to RP plus RS. Therefore, you're going to have R total is equals to R parallel plus R series. R total is equal to what? R parallel. What did you get for your answer R parallel? You got 2. You're going to have 2 plus R series, you got what? You got an 8. So you're going to have 8. Therefore, R total will be what? Would be 10 ohms. Therefore, that means the total resistance of the circuit will be what? Will be 10 ohms. I hope you understand. Okay. That is how you go about calculating the effective resistance of the circuit. Okay. Question number 2 says that calculate the reading on voltmeter number 2. V2 is a voltmeter, number 1. And V2 will read the voltage of both A and B because it is in a parallel format with both A and B. And I said, as resistor A and B are parallel to one another, they would have what? They would have the same voltage. Number 1. Parallel. Remember the rules in terms of parallel resistors. So, the voltmeter read by V2 would be that of both A and B. So, how are you going to go about calculating the resistance of both A and B? So, the easiest way you can do is by looking at your data. What do you have? You do have the total resistance of resistors in parallel, RP, which is what? Which is 2 ohms. And you do also have the current. Remember, guys, to summarize the things, I don't know if this is a shortcut or what, but yeah, I think it's the only shortcut you can use. The reading of resistors that are in parallel. When you calculate the resistance of resistors in parallel and you combine it into one, and not 3 or 6 separately, but one resistance in total, you will regard those resistors as one resistor that is in series, and a resistor that is in series that has a resistance of 2 ohms. I don't know if you understand. To avoid confusing yourself, because the mark allocation there is 2 marks, so you can't go around calculating the current of A, calculating the current of B separately whatsoever. The only shortcut that you might have to suffice the mark allocation and not to waste your time in one question, you'll do like this. As you can see, resistor A and B are resistors in series, in parallel. Okay. And in the previous illustration, we've calculated that the resistance of resistors in parallel is what? Is 2 ohms. You've got to worry, it's 2 ohms. Now, the resistor for resistance in parallel, you will regard it as the resistance of one resistor. Regarded as a resistance of one resistor. That is what? That is 2 ohms. If that means you might be dealing with a resistor that is in series. Once you regard the resistance of resistor in parallel as one resistor, which has 2 ohms. Do you understand? And therefore, it will be easier for you to establish the current. Why? Because resistors that are in parallel, in this instance, it's no longer a resistor that is in parallel, but it is one resistor. And it is regarded as a resistor in series. And go back to the rules of resistors in series. I said what? If resistor is in series, what will happen? It will have the same current as the what? As the total current. Therefore, it means what? The current of the total or not the total resistor, but that one resistor that you've created in your head, which is 2 ohms, would have a total current of what? Of 0.6 amperes. Because why? Regarded as a resistor in series, and rules of resistors in series is that if a resistor is in series, it'll have the same current as the total current, which is 0.6, to avoid overcomplicating yourself and to suffice the mark allocation. And then, what you're looking for the voltage that will be read by voltmeter 2. Go back. Voltmeter 2 will read the voltage of both A and B. But in this instance, you've created your own resistor in your head, which is a single resistor that has a resistance of 2 ohms. So, whatever voltage that you're gonna get for V will be the voltage of both A and B if they were parallel. But in this instance, if it is a series, the voltage that you're gonna get for this instance, when you add it with the voltage that is read by V3, they're supposed to give you the total voltage or the EMF of that specific bit. I hope you understand and I'm not confusing you. This is just a shortcut to avoid writing long things and looking at your mark allocation, you're only given 2 marks. So, go back. Which formula do you have that has voltage, current, and resistance? V is equal to IR. Therefore, V is equal to current, which is 0.6, and then your resistance, which is 2 ohms. Let me go and get my calculator. Please give me a few seconds. Okay. So, what you're concerned about? You're concerned about the voltage of V2. So you're going to say 0.6 multiplied by 2 and your answer would be 1.2. Therefore, the voltage read by V2 would be what? Would be 1.2 volts. Or you can do it in another paper where you calculate the voltage that got divided whatsoever to see if the answer that I've got is correct. But this is the only shortcut I could think of. Or if you have resistors in parallel, regard them as one resistor. Once you've calculated the resistance of resistors in parallel, regard it as one resistor. And if it is regarded as one resistor, regard it as a resistor in series. And if it is a resistor in series, remember the rules of resistors in series. Current remains the same, but the voltage splits. I hope you understand. Okay. And then question 7.3.3, they say, calculate the amount of charge. Calculate the amount of charge that is passing through resistor number C in 20 seconds. So you're looking for Q. That's what you're looking for. What do you have in the illustration? You do have the time, which is 20 seconds. So you don't need to convert. When what you're looking for Q. Which formula has both Q and T? Is this one. I is equal to Q divided by change in time. By looking at your illustration, angara resistor C is a resistor that is in series. So you already have the current. Current that passes through C is the same as the total current. Therefore, you're going to substitute. Current, you got 0.6, which is the total current, is equal to Q divided by the time, which is 20 seconds. You'd multiply both sides by 20. Therefore, you're going to have Q is equal to 20 multiplied by 0.6. And therefore, you're going to have 20 multiplied by 0.6, and then you're going to get a 12. Therefore, the charge that you have in this instance is 12 coulombs. Then you get your 3 marks. Simple. You're going to get a mark allocation because you substituted the correct answer, the formula, and the final answer. I hope you understand. Okay. Question 7.4. What are they saying? If bulb B fuses, bulb B is the one that is parallel with bulb A, resistor B. How will this affect the total current of the circuit? So, write down increase, decrease, or remain the same. Give a reason for your answer. So if they mention the aspect of fuse, they refer to the fact that, let's say, for example, bulb B might be removed as a resistor in this instance. And as it is removed as a resistor, what will happen to the total current of the circuit? So, removing one resistance, what effect would that have on current? Go back to the relationship between current and resistance. Resistance is inversely proportional to current. What does that mean? That means an increase in resistance results to a decrease in current, whereas an increase in current will result to a decrease in what? In resistance. That is number one. So, if you remove B as a resistor, what will happen to the total resistance of the specific circuit? The total resistance would what? Let's calculate. So, you remove B as a resistor. Therefore, your total resistance would be, you'll be having 2 resistors that are in series, which means you will have 3 plus what? plus 8. And therefore your total resistance will be what? Would be 11 ohms. What has happened to your resistance? Your total resistance, initially you got a what? You got a 10. And now since you've got 11, that means what? Your resistance has increased. And as your resistance has increased, what will happen to the current? The current will decrease. It will decrease because of why? Inverse proportionality, the relationship of inverse proportionality. So, as the resistance in this instance has increased, what will happen to the total current? The total current will now then decrease. I hope you understand. Let's calculate to see initially the total current they said is 0.6. Now let's make a calculation to confirm your total current will decrease. So, data. What do you have? You do have the total voltage, which is the EMF, and you got it's 6 volts. Number one, the total voltage. The total resistance you got it's what? It's 11 ohms. Now you're looking for the current to see what effect did this have on the total current. Therefore, V is equals to IR. You substitute your voltage, you got a 6. Is equals to your current, you got what? You don't have it, that's what you're looking for. Multiply by the resistance, which is 11. Divide both sides by 11 to have I as the subject of the formula. Therefore, I total is equal to 6 divided by 11. 6 divided by 11, it'll give you a what? A 0.54 amperes. As you can see, the initial current that you had, the total current initially was 0.6. Now, after you have removed one resistor and the resistance had increased, or the total resistance had increased, what happened to the current? The current now had decreased. This suffices to the relationship or once you increase your resistance, your total resistance increases. What effect will have to the current? The current will decrease. Therefore, in the question for 2 marks, if bulb B fuses, how will this affect the total current? As you removed bulb B, what happened? The resistance increased. And as the resistance increased, what happened to the total current? Your answer will be your total current decreases. Give a reason for your answer. Resistance and current are inversely proportional to one another. Therefore, in this illustration, as the total current has increased, it led to the effect that as the total resistance had increased, it had led to the effect that the total current will now decrease. This is why initially you had 0.6 and now you have 0.54. I hope you guys understand. Thank you very much.